Air conditioning unit GRI split system. Error code H3, error code H3 on GRI. H3 error on the GRI system. All right, let's proceed. Okay, let's go. H3 error on the GRI system. The very first thing you are going to do, you will take, let's go here to the bench. Initially, it is essential to comprehend the significance of this particular error. Does anyone have knowledge regarding the meaning of this error? I am not certain. I do not commit error codes to memory. Therefore, what is my course of action? What should I do? I consult the master of error codes for guidance. Right? The great master of error codes. Let's go. Let me post it here on the bench. Let's go to the bench. Let's go to the bench. Bench. Here is our esteemed master of error codes. The moment to color the screen has arrived. The moment to color the screen has arrived. You will receive the contact number of the master of error codes. This is an artificial intelligence. Complimentary, a present from me to you. A present from myself to you. Save this contact number and send her a message on WhatsApp. Hello, does this artificial intelligence assist you with error codes? What have I done? I came over here to the master and inquired. The error code H3 in GRI systems. I inquired and it provided the response. The H3 error code in GRI brand appliances may possess slightly varying interpretations depending on the particular model. Based on the information stored in my database, I have identified the following occurrences for the EH3 error code in the GRI model appliances. Then he will say, GRI air conditioner, floor ceiling on off. Am I interested? Conventional. I don't want to know. I'll skip it. It is not conventional, it is inverter. Gree air conditioner inverter, Eco Garden, protection against high current or low voltage of the compressor. Likely causes encompass compressor overheating, an excess of refrigerant gas, a blocked capillary tube, low voltage in the electrical power grid, or excessively high current. It gives you options, right? For you all there. Or it could be the GRI K7, which is the same thing. Protection for high current and low voltage of the compressor, but it causes the same failures in the compressor. All right, then there's a huge text here that sends recommended checks. You will mention inspect refrigerant pressure levels, electrical voltage readings, electrical connections integrity, compressor temperature conditions, internal component status, and so forth. Possible solutions include adjusting and correcting the refrigerant flow charge. It will highlight the refrigerant flows as it is a training, almost like a course it provides. I mentioned the split inverter because I wanted to know about the inverter. You mentioned the split inverter and the RDA3 code based on the information available in my database. The RDA3 in GRI devices may indicate compressor protection in inverter systems. Specifically for Green Verteco Garden and Green Verteca 7, the H3 code points to protection due to high current or low voltage of the compressor. Certainly, the error signifies elevated current or diminished voltage. Elevated current or diminished voltage concerning the compressor. That's the small board we'll revisit later. High current or low voltage. High current or low voltage. High current or low voltage. That's the error. Folks, you need to start by analyzing the error code. Otherwise, my friend, you'll be working for free. You'll be wasting time. And here we're working with productivity. You ought to be genuinely concerned if you take an excessively long time to resolve a particular issue. This bothers me. Every moment what I'm doing here, look, I spent the day at the bench. Today I spent the whole day here. Yeah, trying to make some stories to post for you all. Really cool. I've already posted some today. I spent the day here in the lab. Throughout the entire duration of my presence here, from morning until evening, I am continuously evaluating my level of productivity at each and every moment. What is the reason for this? Every single moment of my productivity, every instance I'm stationed at the bench or engaged in work must be productive. It must yield some form of result. And each time, look at how it works in my mind, and I want you to model this. Every single time I advance my knowledge, I elevate my expertise to ensure that each and every hour I dedicate to a task I'm engaged in at the company, that particular hour is effectively multiplied. Pay attention. No, I'm not understanding. I'm at the bench. I'm on the board. Analyzing the board, I spent the whole day on the board. If I'm just starting, it's okay. But this has to bother you. You can't get comfortable with this. It has to bother you. In the game we play today, if I spend the entire day on a board like this, I've lost money and time. Unless I'm studying the board. Then I'm saving time. You observe there's a nuance. Therefore, when you're examining a highly productive system, it is necessary to reduce your analysis duration. Unless you are engaged in studying, and studying is truly the study, indeed it is. For you to conserve time, I spent, for instance, half of yesterday. Since yesterday there was the electronic slot, correct? So I was only able to work in the morning at the bench here, and today the whole day. So it's 3 shifts. Let's see, 3 shifts. 4, 4, 8 plus 4, 12. I will record 12 hours. I was examining a board. However, that particular study produced for me and it will generate what is commonly referred to in the field of finance as compound interest. What I am going to earn from these 12 hours that I am investing, there will be additional hours spent on this board in the future, but how much it will generate for me financially, I do not even know. So it is definitely worth it for me to remain here with my detailed analysis today. My time is indeed valuable for me to stay here. For now, today, at this precise moment, during these days, it is truly worth it for me to be here at the bench on this board. So consistently conduct this thorough analysis, all right? Consistently conduct this comprehensive analysis right from the start of your maintenance tasks, because it's something I didn't fully grasp the significance of, my friend. When I initially began, it didn't particularly matter. The organization I was employed by did not assess productivity. I pushed myself because I knew the more I did, the more I earned. There was a variable. I pushed myself, but it wasn't close to the pressure we put on ourselves today. From production to doing to analyzing to understanding that I'm taking too long, I'm going to lose. There comes a time when you, again, unless you're studying. Why do I advocate for studying? Because if I take this board, which I have never seen this board in my life, for example, and then I will analyze this board. And I, having never seen it before, will take a bit longer because I will study some circuits, I will analyze some circuits. I am anticipating the time because more boards like these will come. And when it arrives, I'll be super fast because I've invested time in it now. So I'm investing time now, which takes a little longer for me to make money in the future. Because in the future, when more of these boards come, I will be faster in the analysis. I'm starting to have this perception, this vision. If you have this vision from the beginning, you will understand the importance of stopping and waiting for the machine to show the error. Because knowing the machine's error, whether it's high current or low voltage, was what she didn't mention, the error code. Being aware of this information already accelerates my analytical process significantly. It significantly accelerates my analytical process, correct? Therefore, it is crucial to search for the error code to be more assertive. But there's this perspective behind it. I think I've never mentioned it here. I talk more about these things with my students here openly on YouTube. Like in the free content, I talk less about it. I can talk more. Why? Because it is essential for us to possess that intelligence and that perceptiveness to comprehend where it is worthwhile to focus your attention. If I picked up this board 10 times and each time it takes me a while to repair, I'm doing something wrong. If I get to the client's machine and just remove the board because it's a board, am I doing something wrong? So once more, I search for the error code. Error H6. Was it H6? H6 was from the previous week. H3. H6 was from the previous week. H3 at GRI. GRI H3. Memorize it? No. That's precisely why I created the error code. The master of error codes. You took a screenshot there and now you have the master for you all. Professor, there's the Facilita Técnico. It's great. Excellent. Very good as well. Facilita Técnico is very good. The master of the error code is free. Facilita is also quite affordable. I think it's 40 points a year. Here we have everything. Everything that makes time easier. There's none of that nonsense, okay? The master is a present for you. I utilize it. Thus, I utilize it. I crafted it for my own use. However, it was an encore performance for everyone. Anyway, with the error code, my friend, then we shall interpret. Interpreting is faster than fiddling with the board. Remember today's first philosophy. I'm going to emphasize this philosophy a lot today, because it serves as the fundamental premise to guide your analysis on the board. It's about contemplating in terms of productivity. Always weigh it on the balance. Your decision-making criterion, starting from today onward, is whether that time investment you are making will indeed generate a return. Will that indeed generate a return? The time you're investing, I'll spend all day here tomorrow on this board analyzing it because I don't know it. So I'm investing in my knowledge. Thus, I'm anticipating the future. I spend time on it today to make more money faster in the future. This is the mindset you should have. This is the perception you need to have. Then you will guide your decisions, including business ones. What am I going to do? Should I invest in board repair? Will it be worth it? I'm going to do this thing. How much time do I have to invest in board repair in this game? All the time, all the time, all the time. I only accept a long delay with a board here at the company when the person is learning. I see the person is learning and he says like, it's okay, don't worry, there's no rush. I'm investing in his learning. Got it? There'll be a loss in repair. Not worth it as it takes too long. It's fine. He learned. Next time he'll remove it. In the subsequent analysis, he will retract that investment. Let's proceed to interpret the error at that point. With the error in our possession, let's contemplate the error. Error H3 indicates a situation involving elevated current or diminished voltage. Why? One or the other, as they are interconnected. The compressor running, what is the formula for power? Who remembers the formula for power? Oh, now I asked something too technical, right? Power, voltage times current, voltage times current. The compressor is operating, and as it operates, it will draw an electrical current, all right? It has a voltage on the capacitor. Let's go theoretically. Theoretically, the voltage on this big capacitor here is theoretically 310 volts, okay? When the compressor initiates its operation, there will be an electrical current flowing through the compressor that measures 1 ampere, and there will be an electrical power of 380 volts multiplied by 1 ampere, which results in 360 watts. 310 volts multiplied by 1 ampere yields 310 watts. I'll make life easier, right? It's just math. Here it is. The compressor is running at 1 ampere consistently. Let's suppose that for some reason the voltage dropped. The compressor has to maintain the same operating power in that short period of time. Although the reverse compressor changes the speed, it has to maintain the same power. If the voltage drops, to maintain the same power, the current must increase. Thus, one is inversely proportional to the other. If one decreases, the other increases. If one increases, the other decreases. Exactly. If voltage drops, current rises. If current rises, voltage must drop. They are connected to each other. That's why the error talks about either the current under voltage, very high current, or very low voltage. Because it was either one or the other that caused this high current or low voltage. He reads both at the same time. Since he reads both, he points out the error in both. So, if I interpret this, look at the interpretation we made. I know the behavior, how the machine works. I'm bringing you this clarity, and I am interpreting the error. If the error is about the compressor starting, then the person noted here, musicality to the extreme. Amazingly, I have the media evaporator with this issue. The fan motor possesses merely a single connector. Please examine the detailed analysis. The error in question is the H3 error on the Gree. You are experiencing the H3 error on the media system. It's different. It is something different. It is not the identical error. Same code, different brands, different errors. Because mine has to do with, look, I just analyzed mine. Mine has to do with the compressor, the functioning of the compressor. Oh dear, the compressor's voltage or current is too high. So my problem is with the condenser. Folks, by interpreting the error, you know where the problem might be. Just by interpreting the error, V equals V times I, exactly. So just by interpreting the error, you are already able to know where the problem is. Just by interpreting the error. So, the problem with this machine is related to the compressor's operation. Okay, is it an electronic board? We'll get to the board, all right? We'll get to the board. But the issues aren't always with the board. The defect isn't always on the board. Let's begin with the most straightforward logic. The principle of Occam's razor suggests that the optimal solution is invariably the simplest one. The best solution is always the simplest. What is simpler? Checking if the current is increasing. Okay? Attach the perimeter gauge to the machine and check if the current goes above nominal. If the current increases, it's one analysis. If the current doesn't increase, it's another analysis. Let's go by analysis. If the electrical current increases, what should I examine? The compressor, any accumulation of dirt within the machine, if it is indeed dirty, correct? And any imbalance in the fluid. Could it potentially generate a higher electrical current in the compressor? Yes, it indeed can. Or even the compressor itself. I'll measure leakage to the compressor casing, measure the compressor, and perform a functionality test on it. Isn't that right? The compressor, no, its electrical current is not increasing. They made a mistake. Remember, it's the overcurrent and under voltage. I'll check the voltage then. I'll measure 220. Did it drop to 220? It didn't drop. I'll measure 310. I'll look for the power capacitor. That one. And I'll measure it. Look, there's no way to turn the board. But you can measure here on these IPM pins. I'll tell you where, okay? I'll go master voltage DC. When you talk about reverse detective, you have that notion. In the course Detective Inverter, which is available on the Blacktronic platform, you also receive the Detective Inverter. In it, I teach how to test and perform basic tests on the board. Allow me to proceed, Master. Please pay close attention and observe the power capacitor. Is it decreasing? Decreasing significantly? 260, 250. Whoa! It is decreasing. Therefore, I will investigate the reason for this decrease. It might be the capacitor, or it could potentially be the reactor. Right? It could be the PFC, something in the PFC circuit. It might potentially be the PTC within the circuit. It's not decreasing. It's not decreasing. And even if it provides an error, then indeed, current doesn't rise, voltage doesn't drop. If there's an overcurrent or under voltage error, then I'll suspect the board. Only subsequent to thoroughly examining the errors that the board communicates to me. Only subsequent to thoroughly examining the errors that the board communicates to me will I proceed to verify, and then I will begin to suspect the electronic board. Because the electronic board is designed to give you the correct error code. It is specifically designed for that purpose. If you do not take the time to interpret the error code, what is the purpose of it providing you with the error code? Sometimes it's right, sometimes the current is high, tripping protection. And there you are wanting to swap the board. Swapping the board gives the same error. Ah, so it's not the board. Do you really need to swap it to find out? Why not interpret the equipment's logic? Alright, after that everything's okay. I arrived and all is fine. All peripherals, the whole machine's behavior. So what should I check? I will examine the level of or inspect the electronic circuit board. Which specific section of the board? I will thoroughly examine the temperature sensors. I will carefully inspect the input voltage, and I will meticulously check the circuit to activate the compressor by accurately reading the voltage. Actually, I will check the voltage reading and the current reading. Got it? Voltage measurement and current measurement. That is all. That's what I'm going to check. Why? Because it's starting from the compressor, for example. The compressor is going down and then the error occurs. But the current doesn't increase, so the reading might be wrong. Either voltage or current. Then I'll check the voltage and current reading circuits. Can I buy the reverse detective now? Yes, you can, Fabio. Yes, you can. I'll talk to these numbers in the description here and they'll send you the link to the detective. Moving on, let's go to the board, voltage reading and current reading. What specific circuit is this one that you are planning to analyze? I will demonstrate it to you here on a GRI model, correct? On a Gree model, isn't that right? There exists a GRI model here, this particular Gree model here, but I desire the logic to be extrapolated to any Gree model, or rather any board model. The very first thing is the reading of DC or AC voltage. Every single voltage reading is conducted through a sequence of resistors that will reduce the voltage. Which voltage? I want to know the DC voltage, the voltage of this large capacitor here. It has a positive and a negative. If I turn the board here, I will see here the positive pin, the negative pin, positive pin, negative pin. Hey guys, how does this guy here, which is a microcontroller, how is it going to read this voltage that's on this guy here? But it operates with 5 volts, 3.3 volts. If I take 310 volts from this capacitor and apply it to it, what will it do? His soul leaves his body and he never goes back to being what he was before. It burns the micro. For this, the micro will take up. The micro is smart, right? He will obtain a sample of the voltage from this component, a sample of the voltage from this component. And it will, with this particular voltage sample, it will be able to determine precisely how much voltage is present within the capacitor. Why? The sample is made using a voltage divider. It uses a series of resistors to lower the voltage to a level the microcontroller can read. For instance, let's say it cuts the voltage. So when there are 310 volts, it reads 3.1 volts. Let's assume it is divided by a factor of 100, correct? This will reduce the voltage until it transforms into a sample that is precisely 100 times smaller. Isn't that correct? 100 times? Yes. 310, 310. That's it. And at 310V, this microcontroller will read. So when it reads 310V, it will know that this capacitor has 310V. If it reads 3V, it will know that this capacitor has 300V. If it reads 2.9V, it will know that this capacitor has 290V, and so on. It wasn't that number. It wasn't that number, but it's like this. It's not this proportion of times 100. It can be different in proportion, but it's in this way, the logic it follows. So, who am I going to look for? I will search for the sequence originating from the positive terminal of the capacitor and allow me to bring it closer for you to observe. Here, you will find these resistors arranged in sequence, all right? These resistors present here, they proceed over to this location, traverse through this area. He just knocked over the tank. What was left of it was intentional. Where did they get this one? I'll show you. Continuity is essential. I'm going to map here and I will track from here to there. It doesn't go here, see? Where are you coming to? It is becoming positive at this point. Okay, he's measuring the voltage before it. Look, he's reading here. He's reading this voltage here, which is before the capacitor. And on this capacitor, see, there's a sequence of resistors here. It's dropping the voltage from here to here to here. And it comes, exits here, you see. It comes up to here, drops here, you see. The sequence here, you see. Resistors. All in series. It dropped the voltage and comes up to here. When I turn here, rotate the circuit board in this direction, and the signal emerges from beneath the relay. The signal emerges from beneath the relay and proceeds to this microcontroller, correct? Thus, I have two distinct voltage measurement pathways here, one preceding the power factor correction, PFC, and another following it at the power capacitor. This particular one is assessing the capacitor directly, so what action will I undertake? I'm about to measure these resistors. Please take note, how much is this particular resistor? It has the marking 1003 inscribed on it. 1003 is equivalent to 103. Therefore, 1.03 corresponds to 100,000 ohms. I'm going to measure the resistance here, okay? It should be 100K. I'll measure it on one of them. It was stated to be 700, which is equivalent to 0.7 megohms. However, it was actually 751 kiloohms. Right? It's wrong, right? Yes, but I'm measuring it in the circuit. To measure it right, I need to open it. So I take one out of the line. When I take one out of the line, I disrupt the series. Then the value of all of them will give their correct real value. I need to open the circuit and take out at least one. I won't touch this one since it's untouched. So I'll remove one here. Removed. When I remove it, I will measure just one outside. There's no need to remove each one individually. Once I open the circuit and remove just one, all the other values will give the correct reading. If there is any alteration, and when I say altered, it means a 4-digit result. It is a 4-digit register, and this particular register is a high precision one rated at 100K. If it is displaying 120K or 90K, then it is altered. The T10 is altered, and consequently, it will impact the voltage reading. If it impacts the voltage reading, the board might display an H3 error, which is an undervoltage error. Therefore, this is a circuit I ought to analyze when I encounter the H3 error. Voltage reading, this one and this one here, are essentially the same. Analyze these two. All the resistors in the circuit are straightforward. They're resistors, all right? It is straightforward to measure and straightforward to analyze. You simply need to open up the circuit. The measurement that you're able to perform on the DC protection board involves measuring from this particular point to that specific point here on the IPM, obviously with a great deal of care, correct? Simply measure from this particular location to that specific location, naturally with a significant amount of caution, from this point, from these 3 points here that are grouped together to this single one that stands alone, all right? Then I have 310 volts. Lawhander, my friend, that is not the particular thing you mentioned earlier. I was unable to find it, but the result appears to be all good. Could it potentially be an overcurrent issue? Let's take a look. Where exactly are you planning to analyze the current? You will be searching for something known as a shunt resistor. Here is one example, and here is the other example. Do you see? These two components here, do you see? This particular one and that particular one. What is this one measuring, huh? It's measuring the PFC here, the IGBT. It doesn't particularly interest me much in this specific case. Initially, no, it does not. Wow, my phone's acting up today. What seems to be the issue with my camera? Please take a look. This one and this one. I'll start with this one and analyze it because it's in the IPM current, the current through the compressor, in the compressor current. Start reading with it. Where does it go from there? It goes to this little circuit here. In the corner, see. It goes to this comparator, this little guy here, see. This little guy right here, it's the comparator. He is considered the primary antagonist when it pertains to overcurrent situations. All right? So this component here, it's in the current, it comes to it, passes through it, is processed in it, and is sent to the microcontroller. So here's the path. I will follow the traces, measure each resistor, measure the pins of the comparator to see how much voltage each pin has to see if this voltage logic makes sense. And then, if everything is okay, or if I find any interference in this circuit, I will find the defect in the board. Basically, we analyze two circuits with the interpretation of the error code, and I only replace the faulty component. Error H3 in the grid regarding overvoltage or overcurrent, you will analyze the circuit that reads the voltage and the circuit that reads the current. First, for voltage reading, the resistor is easier. Second, for current reading, I'll measure the shunting and create a short. I'll check the traces. I'll check the comparator to see if it's altered. The comparator is the most advanced test, right? But anyone in climatronics knows how to test and analyze. And then you analyze the board at the points and the IPM as well, obviously. You would quickly test the IPM here, right? I would check the IPM to see if there is anything unusual, but only if the compressor didn't start. If the compressor worked, I would rule out the IPM. Correct. Later on, if nothing worked out, then I would go back to the IPM because this is an internal temperature issue causing a defect in the IPM, but only if the compressor was working. If it doesn't work, go straight to it and analyze it as well, okay? Measure the IPMs, measure the output of the IPM, the power section, and the signing part, fault pin. It can also cause overcurrent. All right, team, agree. Please proceed with this task. Follow all of these analytical steps thoroughly. Utilize all this analytical logic to rectify the H3 error. I hope that was sufficiently clear. Clearly, I am not going to resolve the error for you. Today's lesson is more focused on analysis, on exploring possibilities. Sometimes I bring repairs, sometimes analyses. In a certain manner, there is quite a lot to learn in this particular lesson to assist you in more effectively interpreting the H3 error. I sincerely hope it has provided greater clarity for you when you come across the H3 error in the inverter. Know what to do, know which seconds to analyze, or rather know what to do before reaching the board, because you can solve the problem before reaching the board. Is that clear? Great! If you enjoyed this lesson, give it a like, subscribe to this channel, and share this lesson with someone. Thank you, everyone. Take care. Goodbye. God bless. I'm out.